Well, good morning, everyone, and welcome to today's exciting webinar on creating 3D mashups by integrating GIS, CAD, and BIM, and probably even other things. I'm very excited to be presenting this today with quite an exceptional panel we've got gathered together. And just before we get started, I'll remind people that... someone's got an echo. Okay. Well, we got an echo. Somewhere there's an echo that I can't stop, but I'll just keep going. I think it might be this one. No?
Did it go away?
I think, yes, it just went away.
That was me.
It was Dave. Thank you, Dave, for that echo. All right, so anyway, that was your chance to tweet on that FME webinar that we're underway, and the echoes have been resolved. So I'm joined today by my good friend and colleague, Kevin Weeb, Chief Scientist of Safe Software.
Good morning, good afternoon, good evening.
Yes. So Kevin, tell us just briefly your role in 3D at SAFE. What has that been?
Well, I think that I would say that I was right from the beginning with the 3D movement here. When I started at SAFE about, what now, 15 years ago,
yes.
16 years ago, we only did points, lines, and polygons.
Yes, that's right.
And I know we had discussions in about 2001 on how to modernize our core geometry model, and I was involved with that restructuring through 2004 when we added objects, 2005 when we added more classes, and 2006 is when we actually started redesigning, and 2007 adding actual 3D support within FME.
Yes, so Kevin has been the primary architect behind all that, and he's here with us today. And I'm sure it will feel good for you, Kevin, to see that work that began all those years ago and really began to be rolled out nearly 5 years ago, all the various things that customers have done with that. We're going to be seeing quite a lot of those cases today. And Kev, what was going on during this picture that was there?
You know, I think that was a football game.
Yeah.
I don't know where you dug that lovely picture up, and I don't know. I'm going to guess that my kids were beside me prompting me on to do something like
that. Yes. Anyway, that's great. And we're joined all the way from Sweden by Ulf Manson. So, Ulf, are you there this morning?
Yeah, I'm here.
Wonderful. So, you know what a relief that is for me. Ulf is going to be talking during the second half of our webinar on some really interesting projects and techniques that they've been doing in Sweden with the 3D capabilities in FME.
Yeah. So should I talk Swedish? I'll stick in English.
Well, I noticed that only half of our registrants are from North America. So to the other half of you, thanks very much for joining. Ulf, are they all your extended family in Sweden, I'm wondering?
Yeah, certainly.
Yes, great. So we're also joined with our panelists, Mark Stokes, Manager of Professional Services, and Dave Campanis, certainly a product specialist here at SAFE. Mark is in a different room, but Dave's in here. Give a nice hi for us, Dave. Oh, he's doing a mime for us. But Dave has been very involved with CityGML and IFC and these kinds of formats, LandXML, really all those kinds of things. And certainly throughout the webcast today, don't hesitate to try to ask Dave the hard questions. We're also joined by our good friend Dimitri, who's not in the room with us here, but he is online, so you can quiz him. He's responsible for so many of the examples that are on FMEpedia and for pushing the 3D capabilities of FME very, very hard and far as well. So just a couple words about Safe Software. We've been around for 93, so a little bit longer than when Kevin is basically employee number 3 or 4, depending on how you measure it. So he's been there almost since the beginning. My name is Dale Lutz. I'm one of the co-founders of SAFE, and today we have about 90-ish employees, all of them pretty well located in beautiful Surrey, British Columbia, where the weather is rainy today. We make this product called FME, which we like to say powers the flow of spatial data, and really to some degree powers the flow of data from wherever it is to wherever you need it to be, and along the way we can do transformations. And so I thought we'd start our thing interactively by asking the folks at home there, have you used FME before or not? So let me launch that poll, and we can get a sense for how familiar the audience is. And so about, looks like about 20% of you having not really used FME very much or at all, and quite a good spread. So we'll just wait for a couple more votes to come in. and I think we'll call that golden. All right. So thanks very much, everybody. You can see we have a pretty good segment, actually almost a quarter that doesn't use FME. So we'll spend a couple of seconds just talking about the theory behind the tool. And to the rest of you, thanks very much for tuning in today. So I'll hide those results. Basically, FME is this product that sits in the middle between a large number of classes of formats. And the trick is that as data is flowing from one class of format to another, we can do transformations along the way. And so we're going to see a number of different examples today of taking data that certainly isn't 3D to begin with, that maybe lives inside of CAD or GIS or even more ancient kinds of things, and moving it into 3D. And this is primarily done through an authoring environment we call Workbench, where you set up the transformation from the beginning, from wherever your data was, pump it through these blue things until you get where you want the data to be. And after you're all done with that, you can save that configuration and then run it over and over again in a batch mode, or you can even push it up to a server where folks can access those capabilities over a web browser or asynchronously in manners like that. For those interested in the server side of things, there's a webinar coming up next, I think it's actually a week from today, talking about using FME in the server to interact with live data, real-time data. Okay, so just a few words on formats, and I was going to hit up my buddy Kevin here. This is I did a quick look through our database, and this is the set of 3D formats that that SAFE supports. And my question to you is, Kev, in terms of what you've seen out in the industry, you were just at a conference recently. Of these, would you say what SketchUp, CityGML, which ones tend to come up most in the community out there?
Currently, in the conferences that I've attended, as well as the customer interaction I've had, probably would be CityGML.
Yes.
I think for the larger projects, that's a common, I guess, focal point where people are focusing their efforts on trying to do, the larger scale tasks in terms of shuffling around between systems, between different folks that need to share it.
Yes.
But there is a wide range of formats that are being used in specific projects that are out there as well. SketchUp is surprisingly also quite widely used for, I would say, less sophisticated projects that are around.
Right. And of course, I know, Dave, you've done work with IFC, which stands, we'll talk a little bit about it later, but certainly a lot of building data in that. All from your perspective, do you end up actually tangling with 3D formats, or basically is the end of the line just cranking up something in FME?
I think 3D formats are getting more and more common in general.
Yes.
I must say that.
Yes.
So it's certainly a trend.
And of course, the 3D PDF is very, very popular as a convenient way to share 3D data, and we'll see some examples of that today. So that's enough on that. So while we're talking about formats, we thought we would ask folks out there, what ingredients would they have if they were going to try to make a 3D mashup of different things? What would they be starting with as their input data? What kind of things would you use as ingredients? So you can choose many options, and we'll just let the results come in there. I'm actually quite curious to see how many folks really have BIM data to begin with, and because that's one area that Kevin would argue that we have just really started to dip our toe into BIM. That's safe.
Yeah,
So,
I think that you can have 3D geometries, but the BIM usage of the 3D and the understanding of the model is a layer on top of simply the geometry presentation that needs to be understood correctly for people who have use cases using BIM.
So we'll close the poll and show that, well, almost everybody, probably not too surprising, has GIS data. Lots of folks with CAD and raster. Raster can be used in a variety of ways when we're making 3D, either to supply elevations, or to supply textures to slap on the sides of things. And I'm very pleased to see so many people having non-spatial as well. So certainly all your ingredients had many of those data types too for what you're going to show us later. Is that right?
Yeah, that's true. Especially non-spatial data to connect and visualize.
Yes, yes. So Oh my goodness, this means it's time for me to do a demo, and I'm a little bit rusty this morning, so let's get into the thing. So what we want to do this morning is to take this kind of a building floor plan, just to kind of give people a little taster of things, and make it into a fancy high-rise. And we're going to more or less do that live for you right here. So I just went on the internet yesterday and grabbed myself, I searched for building floor plans, and I was very thankful that the folks in Anchorage, Alaska make available, they have all the, for their university there, they have all the floor plans for their buildings sitting there, and they got a nice numbering scheme. You can see that the last digit there is the floor number, and so we can bring that up. I just brought that up in the FME viewer, which can view anything at all, and we want to click around here and see what we got. These are walls. Walls kind of all over everywhere. And windows. Okay, we got walls and windows. All right. So I'm just going to get rid of this, and what we're going to do is make a transformation to take that and make it into 3D. So I'm going to go drag that particular file here onto here, and I'm going to take a look at this, and that looks fine. And so we're going to say yes to this. And I'm creating an FME workspace. And all that I want, today I'm only going to worry about walls and windows for my little example here. And so at this point, Dave, you're broadcasting again.
You're broadcasting again.
There, whoops. All right. So he's got to mute himself there, Dave. And so I'm going to, okay, I got walls and windows. And what I want to do is extrude these. So let's get an extruder going. And I need, how many units did I say I was going to extrude these? By 50. So I'm going to basically puff them up into actual up and down 2 extruders. Okay, and this one also is 50. And I think with that, I should have created walls out of those lines. So I'm going to connect an inspector there and one here. And I'm just going to go ahead and run this. And with any luck, it pops up and it shows me what we've got so far. And Kevin likes my gray background. And so there we've got the start of something. But the appearance is a bit sketchy. Like when we're in behind, it looks, I don't really like it. How about you, Kevin?
I don't like the gray background at all.
Yeah.
It doesn't accentuate the walls and windows there.
Yes. Well, what we can try to do...
let's not change the background. Let's change the actual objects themselves.
That's right. Thanks, Kev. We are working on changing the background, but that's a matter for top people here at SAFE. So I'm going to put down a creator. Oh, I should have mentioned, inside of FME, we have this library of transformers here that do all the magic, that let us slice and dice data. There's many of them. And so one of them is called the creator, and I can either find it over on the left-hand side or just type to add. And I want to make 2 appearances. So I'm going to make appearance stylers here. One here, and let's connect this guy up. No, the top thing was for Windows, so I'm going to do the bottom guy first. Actually, I'll make this the bottom guy. And we need to set this. I'll set something for my walls. What's a nice boring color for walls, Kevin?
If you look around our office, I'd say brown.
Okay. All right, that's a good answer. So we'll go with brown for that. And I need to also add an appearance here. Let me just duplicate this guy. And I'm going to make an appearance for the windows, but I'd say I should go with something a little more bluish. How about that for windows?
Yeah.
And then I can do that. What's this alpha thing about?
Well, that lets us change the appearance so that it looks transparent.
Okay. So we're going to do a bit of transparency there. And now, so I've got these appearances, and I need to put them onto my walls. I can click on here, and I think I have to do an appearance adder. Does that seem right to you, Kevin?
Sounds very good.
And I send the geometry to the geometry. That would make sense. And so the appearance, I can have a different one for the front or the back. But today, for simplicity, I'm just going to throw it on both. Does that seem good?
I approve.
You approve? Okay. All right. So that's good. And we're going to drag this, and I can just inject that into here in the same way. Whoops, I connected it in the wrong way. I want this to go to the geometry. I want that to be gone. Be gone, please. All right. And I need to connect that there and there. So with just these many transformers, with if any luck, we've got basically the start of a 3D floor plan here. And so if I flip this around, okay, oh yeah, it's even fine on a gray background now, wouldn't you say, Kevin?
I think it's wonderful.
Let's say our windows are somewhat transparent so we can peek inside. So that's pretty slick. And so that's what we just wanted to quickly show you, how quickly we managed to get that to go. And I have another example, so I'm going to get rid of this. No, I'm going to cancel that actually. I'm going to open a recent one. With any luck, my recent one was the floor plan to a building. No, I won't do that. Oh, that's bad of me. Okay, so I'm going to go here, get rid of this, and I'm going to go find it. It's up in here. This one here, indeed it is there. And this is that same example. We took a few more of the interesting pieces in there and extracted the layers we wanted, extruded them, moved each floor up. That's what we did here. We extracted the floor number from the file name, and it turns out that the last digit of the file name is the floor number. And so that lets us do some math then in this offsetter. If you notice, our Z value or our Z value is being pumped up by that amount. And then we go ahead and do some things like create styles for the walls and the windows.
I like how you've grouped the different sections of your processing there with little bookmarks around them with comments. That makes it easy to follow.
Right. And for anybody interested, we're going to make available all this stuff afterwards, so you too would be able to easily start creating your own buildings yourselves. So here's the results of that. And it's sitting here thinking, okay, we're going to go to 3D. We'll flip this baby up. And there's our nice building, and we can kind of take a peek in. And I can start to throw off the floors here and look at it in that way, and separate out just one floor if I want to. You get the idea. And so that's that. I also quietly created behind the scenes a 3D PDF of this thing.
Oh, so you can output to more than one thing at a time.
I absolutely can. And so let me go to my Finder here, and I think I called it building. Building.pdf. There it is. Building.pdf. So let's see if that's in there. And we'll nervously await the arrival of the building. Yes, there it is. And so there this guy is inside of PDF, and we can see it around. So I could give this to, actually your mom probably could work with this, Kev.
I think she probably might.
And somehow, if I knew how to get my things, I can flip off and on floors here too. So maybe if I want my analysis toolbar, yes. So I can flip off and on the various floors as well right from in here. Because in PDF, we can do things like that. And here I've just kind of taken a nice slice out of the middle.
This PDF, when sent just in a normal Adobe Reader, does not need any extra extensions or downloads.
That's right.
It's a very efficient way that some of the people I've talked to have found to send 3D data to people to just quickly look and view without requiring anything other than what normally is installed on everyone's computer.
That's right. So we went ahead and did that. I also wanted to show, I know my good friend Don said we're going to turn Excel data into maps. So here, and you actually had this example-ish, didn't you, in your case? Oh, I don't know if we might have lost Ulf. That's not a good sign. But anyway, Ulf had something like this.
I'm back.
Oh, he's back. Okay, he was off having a Swedish
meatball. You muted me.
Okay.
Oh.
So no. Anyway, did you have some kind of Excel data along these lines, where basically the grid cells corresponded to parts of the Earth?
Yeah, it was actually one of our brilliant clients who thought up of an entire system like that.
Yes.
In Excel, so that's true.
So what we did was we made a little workspace that fishes those out and basically gets one record per marked cell. Then we build polygons for every one, and from that we dissolved and created walls. And so in the bottom here we involved reading some rasters to make textures. And so we get that thing out, and this only took Kevin and I, how long? Half an hour to put together, and we kind of didn't know what we were doing. Yeah. And so there's that same thing. So you can see that it's pretty easy to start making 3D data from this stuff. So there we did it, and we had some fun with that. Right. Now we're just going to flip through a few other examples. People have done stuff with Google SketchUp. Here's an example of a model in SketchUp ahead of time. We run it through FME. This is the key thing. We only extract the parts we care about and throw away all the rest. And notably, the furniture and all the interior things are missing. And so we end up with a much lighter thing that can be used for purposes of GIS. So really, a lot of times, a common scenario is starting with a rich 3D model and chucking stuff out. That's a common thing with IFC. We can read IFC, and all the data from the IFC is available to the GIS, but in Dave's experience, mostly people want to chuck stuff out and extract just some parts, like, for example, the spaces. And certainly we've got examples like that. You can ask Dave for that if you're interested.
This is often required when original data is intended for visualization purposes, and a secondary use is trying to look at that for analysis.
Right. Right, or even in first data, you might be planning to actually build the place,
right.
But you don't need that. You don't really care about doorknobs and staircases if you just want to figure out what the areas or volumes are, that sort of thing. CityGML is worth a whole morning course sometime, but suffice to say that we do a very good job of all versions of CityGML. It's a bit un-Canadian of us to say this, but we do believe we have the best reading of the planet, and I want to thank our friends at the Technical University of Berlin for supplying us with this particular CityGML file, which has, we believe, an instance of everything that's possible. And we don't just read it, we also write it, and we've supplied our reading to a number of other vendors who include it in theirs. But enough theoretical things where we're just playing. I thought we'd go through a few real-world things, and this is actually an Apollo 11 shot, and I think it's appropriate because today's the day when the SpaceX capsule is going to land. Did you know that, Kevin?
Nope, no idea.
So SpaceX has had a capsule up at the space station, and we want to be finished this webinar in time for you to watch that. So I'm going to go through these very quickly. First one that we've got is an example, and when you get these slides, you can follow these links where the town of High Level took photos that were from the street and orthophoto from the top and GIS data down at the bottom of the building heights, and we could create for them a 3D model that's relatively realistic of their town. Of the town things. We threw in some light posts as well for good measure. Our friends at Shell have taken data from a wide variety of sources, WMSs, WCSs, well paths that are in an Oracle database, and produced 3D PDFs of where their wells are, and they do this through FME server where their geophysicists can go and put in a little area that they're interested in and bang, get a 3D PDF that they can work with. It's been very, very popular. Our friends at UMass, I got to give high praise to our friends Alexander and Niels LaCour, Alexander Stepanov, great FME users. I got a couple examples. One was this: they were tasked recently with generating realistic shadows for proposed buildings, and so they made wireframes using FME, and then transformed them in 3D. I think, Kev, you guys have a 3D affiner, don't you?
Yep.
And so they sheared them somehow, tilted them in the direction of the sun, like the sun is pushing them over, and then drop that back down to the ground, and they get these kinds of things. Ultimately, they fish out just the shadowy parts, and then are able to present that back to their end users on a nice-looking 2D graph like this. So I thought that was pretty fancy. They also have a long-time example where they're using the data interoperability extension together with ArcGIS Server to transform buildings in much the way that I was doing at the beginning, but a much more sophisticated way through FME, through FME technology and data interop, through ArcGIS Server, ultimately for helping with facilities management at the university. So they start with CAD drawings, much like the one that I had this morning, only more tricky, they're in their own local coordinate system, and they have to convert them, again using FME or data interop technology, using least squares and the Python capabilities inside FME. They end up fitting those drawings into the real world and then extruding them, stacking the floors on top of each other, and then they go out to a database to attach the information that goes with each room, creating a complete room model really in the whole for the whole campus in ArcScene. And you can get at all the attributes of every single room and do analysis or other kinds of computations from that. So really quite an interesting and sophisticated example, and they've been doing this kind of thing for several years there. But with all that, I now want to hand it off to our special guest all the way from wherever the gods live. I can't remember the name from the movie. Is it
Asgard?
Asgard. All the way from Asgard, we have our friend Ulf Manson, and he's back visiting Earth right now. So thanks for joining us today.
Oh, thank you very much.
And Ulf, I'm going to give you the con here if I can figure this out.
Make sure it's Ulf and not
I say
Loki.
this is the first time my son really was impressed by my work when he saw this picture.
Yes. So I don't know how to change the presenter now. Where's my panelists? Can Roger do it? Oh, organizers. Oh, maybe. Oh, Roger has done it. Okay. Thank you very much, Roger. And I guess you're now got a hand. Oh, Ulf, you probably have to show your screen. There we go. And we're in business, and I'll hand it over to you, Ulf. Take it away.
Yeah. Does it look all right now? I think so.
Wonderful.
Yeah. Thank you very much. Well, I'm going to talk about a use case where we used FME together with a client in a decommissioning project of a nuclear power plant. So first starting here, the first slide here, when I started using FME, I think it was 15 years ago, I never thought of it as a tool to create stunning graphics, but what we see here is actually a 3D PDF in this area produced by FME, and also the smaller pictures here are from the data inspector. So this is sort of an aerial view of the power plant, and the small little pictures here are displaying results of the sampling radioactivity in there. So I also want to give some quick credits here, especially to some brilliant people at the nuclear power plant, very innovative and brilliant engineers, and as you might notice, all have the same name to begin with. It's Lars. So I think being innovating means you can have the name Lars there. And also, of course, to my coworkers at Sweco. I don't have a lot of corporate information, but it can be good to know that in Sweco we do have more people employed than just FME nerds. So we do have people who actually were around constructing the power plant, and they really know the nuclear business and other utility sectors there. So we're not just a bunch of FME nerds running around in a nuclear power plant. That can be safe to know that. So just some quick information about the background here. You can see the blue dot. That's where I'm currently now. I guess you guys are over on that side there. So Barsebäck power plant is situated not far from here. It's about 20 kilometers from where I'm sitting right now, and it was constructed in the beginning of the 70s. But in 1980, we had a referendum in Sweden where people voted and decided that we should quit making new nuclear power plants and we should stop the existing ones. And that should be done, I think the referendum said that should be done by 2010 or something like that. But so far, the only one that actually have been stopped and taken out of production is this plant, Barsebäck power plant. So it was completely taken out of production in 2005, I think. So it's been in service mode since then. So that's the background, and it is in a decommissioning phase now. So that is there is a project that will go on for a very long time because it's very complex to figure out how to dismantle it and what the place should be used for after dismantling. So in decommissioning, it's very important to have an initial radiological survey of the area, of the plant. And that is because it's very important to estimate how much contaminated material there is in this plant, because it's very important to handle contaminated material. Just working with it is more complex, but also it's supposed to be stored somewhere in the world later on, and storing contaminated material is of course very expensive. So getting a good estimate of that situation is very important. And the theory here, when we began this project, was that the 3D model could help with that. So help with planning, acquisition, and visualization of sampling data was one idea. And of course, if you have a good 3D model, you can help with the logistics in the actual dismantling process and in the planning of the process. And we also do believe that seeing is good for checking quality. And if you can see data in 3D, it adds another dimension to quality assurance. So as I mentioned, the plant was constructed in the early 70s, and basically it was done on drawings, and thousands of drawings. So that's actually the originating documentation. And of course, that documentation at some stage was scanned into a computer as rasters. And there was a big project that converted them to AutoCAD files. So that was the source that we could work with to try to create some 3D out of this. But it's flat 2D CAD files in that case. But I must say it's very accurate information they have at this plant. All documentation is really very accurate and in good shape, even if one can think of it's in an older way of storing it, because of course if you build a new nuclear power plant, you're probably using BIM or something more advanced in 3D. But this was constructed in the 70s and was shut down in 2005. Just to show that the rasters have been vectorized, I symbolize that with a little square there. Now, what we did and how we used FME was that we started working with these CAD drawings in a similar way that Dale just showed, that we set up a transformation pipe where we added control points to existing CAD files. So defining each floor with a control point, but both in X, Y, and Z. So we get both the real coordinate in 2D and in 3D for each floor. And I should mention this while I remember it, the power plant has its own local coordinate system. So what we do in the transformation process is that we cut out each floor, because there are several floors there can be several floors in one drawing. So we cut out that and we do the extrusion pretty much like Dale showed before, and we stack the floors on top of each other's. But during this process, we also try to maintain some sort of intelligence. We try to keep intelligence in the model, and we see there that we have connected an Excel file with data. And an important thing to keep in this are the room numbers, which is very important, I think, in general in nuclear power plants, because all documentation is often connected to the room numbers. And by doing this, we can connect and visualize results. In this case, it's mostly about results from the radiological survey. Now, if we look down to the right here, here's what the more simple extrusion looks like. It's not that super fancy for each room, but you get the height and the width of the walls, and you also get a simple door opening in that. But we do some more fancy. Yeah.
On this one, I noticed you have a label there, the V03. Does that is that picked out, or do you do something more interesting with that?
Yeah. That's the room number or the room ID. And we actually use that. If you look at the picture up to the left, you see an elevator shaft going through the floors, and that's one solid object. And that means that room have the same room ID, even if it occurs originally from different drawings.
Okay.
So what we do is that we try to maintain those as one object, even if they cross several floors. And that's also what we can see, that we have punched holes in the floors and ceilings in the model. So it's a bit more complicated than just doing the extrusion. We get holes in the building. Now, in this process, we use FME, and the great power is that I think that we can use so many different sources and do a lot of stuff with it at the same time. We have a digital elevation model for the entire plant, which is very high detail. we had the CAD drawings that I just showed. We went to land use information. We had different kind of map data, of course, different kind of tabular data, and all this is entered into FME, where we we mash it together. That's a good word, I think. And a good thing with this is what we can decide what we would like to output. We do output a lot of 3D PDF, but we can also write three-dimensional AutoCAD files, and of course 2D if that's wanted, even if we stored this in 3D. Now, this is another screenshot from the actual model. As I see there, you can see there is a room. We are marked there with a room ID, and this is very important to be able to search for a room and display it like this. And we have another thing that is.
So Ulf, that's searching. Yeah. The searching, Ulf, is that just part of Acrobat Reader that you did that in that previous one?
Yeah, we can say that. In this case, we just have clicked with in Acrobat Reader, but the search capability is very important when we connect data, and we often do that with FME. Say you have an Excel spreadsheet with data for a room, then we can connect that and output a 3D model for that.
So then you see all the properties of that room.
Yeah, that's true.
That's
true.
Okay.
In this case, we also make cutouts, or I don't really know the best word for that, but that is that we show a part of the building together with the ground in this case, and that means that we can, first of all, it gets a bit easier for the user to find a specific room, see just the surrounding areas, because it can be hard to navigate in a complete 3D model. And in those cutouts, we can also turn on, say, the floors above the specific room I look at, but we can also turn on what's below the ground. So this is also from a 3D PDF, but we're looking at part of a building from below. And I think I'm going to try to show, let's see, I'll take up more a 3D PDF here. So here we see an aerial of the power plant like this, but I'm actually running live. I don't know if it's streaming good.
Yeah, we can see it, Ulf. One thing I wanted to ask you, didn't you used to live right over there on the far left of this?
Temporarily, we rented a house that was very close to this one. So when we woke up in the morning and have a breakfast, we could look straight to Unit 1 of this one here.
How do you think you got your powers?
That's how you got your powers, I guess. That's
that's
true.
That's excellent. But the thing here is, and what's very good here is that we can see, if we actually peek in here, we can see that we have colored dots in here, and these are results from the radiological survey that are fed into the model. So we can see results from that both from the inside, and we can also look at results on the outside. And that's one thing we can do with FME, to combine the data sources and display it like this. So I'll try to flip this one around.
So Ulf, those results, do they come in, must be from like spreadsheets or databases or something?
Oh, it's a bit more complicated like that, just saying that. But we can say at one point there are in Excel, just before we feed them into the model. So let's say like that. And we can go to an area here where we have colored, depending on the result. Here's different colors. Well, it looks a bit dramatic, but it really is not that very high radiation levels or so in general, as I understand it. So this is a fairly complex 3D PDF, and it really works pretty well with those. They can handle a pretty big amount of data. Let's see if I can go back to the slide here. Yeah, and another way here, when they do the actual sampling, collecting data, they do that both indoors and outdoors, and we use FME here too, in a way, because in the model we just define a grid for each room, you can see the numbers in here. So that room we highlighted there, it also has a grid. And that means that they can make printouts of this 3D model into 2D. This is actually a PDF created from that model, and you can make notes on that, where you have taken samples in the room. And there are a lot of rooms. I think there are over 2,000 rooms at a site like that, so it's almost like a small town. So this is where they can mark where they have taken the samples. And what we do with those samples, if you look at that printout here, we have tagged them with a QR code, a custom transformer we made for that tags the paper with where it is in 3D and also the name of it. So we can bring that back into the model. When we receive those prints with notes on them, we run them through FME with something we call a QR detector that detects the QR codes and extract the true coordinates. So we can then position the printout, but also by some image analysis, the actual dots that have been marked. And that's the way how we collect the position of the different samples. And this is an example.
This is quite an amazing. It's quite an amazing integration of a number of technologies that ultimately end up being a very low-tech way for data collection, but very accurate.
Yeah, and the reason is, of course, that there are technologies for positioning indoors, of course, but it's very complex to do that in a nuclear power plant where you have, say, a meter thick concrete walls and getting stuff to work there. I'm certain there are technologies that could be used, but it's a fairly complex process to get that running. So this was...
To be very, very clear, Ulf, that QR stuff, that's custom transformer that you guys have written. It's not part of FME, but the gods in Asgard have figured that out, and so I guess that's something that you've extended FME with.
Yeah, that's true. It's fairly easy to make a transformer that writes QR code, but it's a bit more complex to find them in a raster and use it like that. So that's when you need some form of custom format there, a custom plugin. So this is a view where we have collected those results and displays it in the 3D model. Now, the outdoors, where you collect data outdoors, is in a similar process. It's also based on a tiling scheme out there, where you perform the radiological survey, and like I say, it's a bit more complex than just going around with a Geiger meter. It's really very impressive how they do this, and that's because you have to figure out how to filter out background radiation and stuff like that. But basically, those points are collected in a similar way, we can say, but and those are also fed into the model. So what we can display is both indoor results and outdoor results at the same time, and that is something very powerful when you analyze data, because you can see if you have relationships between the inside of the buildings and the outsides. So I'll try to run a little movie here at the end. I'll see if I can get that working. Okay, and just some more slides on the intelligent papers, try to explain that process again. As you see, when we scan those backs, the actual prints are positioned in 3D where they are, and you can see those cylinders here. This is where we position the samples, and this is also done with the FME, with the raster capabilities and some image analysis to actually filter those out. And here is a view where we can see all of these points that have been collected. Let's see, I will try to run a movie here and hope it streams well over the internet. Showing here. Here's one of the workbenches. As you can see, it was a bit more complex than the one that Dale showed, but it's very much the same techniques. And here are some example that we also output more regular maps from this model, and how we can tilt things around. And as you see, we have the results from inside of the building. And I'll stop this one here. A good thing about this is that as we get all the information into the same coordinate system, we can also include 3D models that already exist. In the plant, they have very detailed models of certain areas, for instance, the reactor. So this view here is created by using FME to read a very high detail AutoCAD DWG file and combine that with the extruded wall, so we can see that it all fits together. And you can see it's a very detailed model here. And how I'll just end the presentation here with showing how it looks when we have positioned those scanned papers, that we can see that they really are in the 3D space. And here we extract the actual surveyed points into the building there. So yeah, here we see it's. I think it's more than 3,000 points that have been collected, and we have results of radioactivity in all those points. I think it was pretty much all I had to show. But Dale.
Okay, so we had a couple questions before we move on. One person has asked, for this job, did you rely on the original plans as accurate, or did you conduct an as-built survey to verify them? If so, did you use laser scanning to do it or not?
Oh, that's a good question. We're actually working with it now with the accuracy, and what we are using are benchmarks that already exists in the power plant. There are small copper plates all over the plant that were put in there while they constructed it, where we have the actual points. So we're using those to control the accuracy of the model. Now this is a first initial survey, so we don't aim at having the same detail as a laser scan for each room, but we can probably use this model to decide which rooms should be considered for laser scanning, because if we can exclude entire areas of the plants with less contamination, we probably don't need a laser scan for that area. So.
Right, very good. And the other person asked an interesting question. It's more to do with our 3D PDF. He said, in the Plan 3D model, it seems like he saw lines in 3D. Can you explain what they were? And I'm not sure if he means, can we output actual line objects in 3D, or if it was just the wireframe. But in your experience, Alf, do you always have to extrude things, or can you output actual line objects to 3D PDF?
I'm not really sure. The way we would do it, if we were to write a line, we would probably say enter, and we needed to extrude it. We would probably just enter a small buffer around it and extrude it. So we haven't really thought of it as a problem like that.
I guess the other interpretation of the question is that maybe some of the lines that we saw might have been roads and other kinds of sort of physical features. I don't know, precisely what the person was asking, but that's still, useful to know. I think I recall we can't output an actual line object to 3D PDF. Would you agree with that, Kevin?
I think there is some restrictions there in the current FME 2012.
Yes.
Yeah.
So anyway, Roger, maybe you can make the Vancouver site or the Surrey site the presenter again. Let's see if we can. Thanks very, very, very much, Alf, for that. And we'll just continue on, and Alf will be available to answer some more questions in a few minutes when we wrap up. Many of you, I think, will know another great Swedish export, which is Minecraft, and my son was excited to build his own model of the Barzabak himself, which I've got a screenshot of here. And I just would point out that one of the advantages of privileges of working with Ulf is that when I was in Sweden about 1.5 years ago with my lovely wife, and Kenneth Safe was as well with his, we got to bring our wives on a once-in-a-lifetime tour of a nuclear power plant. And we walked by places where the Geiger counter was ticking, and into places that were almost, borderline claustrophobic, and it was just a fantastic experience, a great place to take that special person in your life.
An anniversary trip.
Yes, that's right. And I told her, if you think that the tour is exciting, wait till you see the gift shop at the end. And it was really, really quite something. So anyway, I guess you could say that I do know how to show a girl a good time. And thanks, Alf, for being my wingman on that.
Oh, it was a pleasure.
So, Kevin, you're the guy that I think coined the phrase that you said that 3D is the format of human beings. What would you say to that?
Yes, well, I guess that came from discussion that we often get, because at FME we deal, at Safeway with FME we deal with so many different formats. People say, well, what's the best format of them all? Or what's the one that's the most natural format in it? You know, there is no one. It depends on what your use case is. But in this conversation that we were having, it was around lots of projects that involve decision making, and where human beings are involved in decision making. And I'd say the majority of projects have human beings involved at some point in making decisions from the output of data analysis. And the most natural way to present data to people for us to make best decisions on it is in a 3D format. I know that I used to work in construction, and there are a lot of people who are very comfortable with blueprints or floor plans, but I must say that they must not be humans. That there must be some alien DNA in them somewhere, because it just does not seem natural to express things easily in a blueprint or a floor plan. A 3D model just seems as realistic way that we are designed as human beings.
Yes.
To interact with data, to make intelligent decisions, and having the world of spatial data move towards 3D representation, I just see as natural.
Yes, very, very much so. And you know, I was corresponding with my friends at the University of Massachusetts in the last couple of days, and I just threw in this quote from them, which I think, Kevin, you haven't really even seen this yet, but it's really, really an interesting thing that combines with what Kevin said. He says the limitations to think in 3D, even if all the data are 3D, is artificial. With FME 3D transformations, we can think in 3D, being format agnostic, and solve difficult problems faster and in a more elegant way. Because all the stuff that Ulf showed and everything else, if you had unlimited time, you could write C++ code or Python code or whatever to do it, but Ulf would still be working on the first parts of the whole problem. He wouldn't be showing us results like this. Nothing prevents us from constructing 3D objects from spatial and non-spatial sources. And we saw that throughout the whole survey of things today. The knowledge of the subject domain is important, but the technology is there. So thanks very much, Alexander and Niels, for that great quote, which I really think does sum up what we saw today. So just before we part ways, I know Kevin has got a big, long list of future initiatives to do with our roadmap here at SAFE. And one thing we wanted to just get folks' opinion about is what things, you've seen all this stuff today. Kev, you mentioned volumes. I know we saw some questions rolling by from folks about volumes. Is that one thing that you think is possible?
Yeah, well, I know that I've been biting my tongue here because we have been focusing our webinar today on FME 2012, which is our current shipping version. And in the pipeline here, there are quite a large number of additions in terms of 3D processing, 3D functionality that we're adding for the next version of FME. And the things that will be possible with the greater number of processing things is going to be amazing, I think, when we have the next version of Ulf's demos out there.
Ulf 2.0.
Yes.
So, yeah, I know one thing, the 3D validation, that's about if you say you've got a closed building, is it closed or not? Yeah. And then if it isn't closed, can you fix it?
We're trying to obviously hit a lot of the pain points that are out there with current 3D interoperability or 3D processing with the next version of FME. And one of those we've heard loud and clear is that people who are working with existing 3D data for one use do not see it as fit for purpose in another use. For visualization, not quite clean 3D data that's not really closed and not quite perfect is no problem because you're just flying through it. But once you try and analyze things, you can't calculate the volume of the rooms in a house when there are open doors or open windows to the outside. Right. The mathematics won't work. So being able to help repair or detect and repair certain things is quite a big problem that we're biting off for 2013.
Revit has also been floating around out there as something that we should bite off, and it looks like the folks indicate that they're interested in that as well. And 3D buffering would be, let's take a line and make a pipe. And I know there was a question earlier, somebody asked, can they put pipes into a 3D format? And the answer is, if you have them already, you can. What we want to do with FME is be able to do something where we just can take a single line through 3D space and then wrap a pipe around it. I bet, Ulf, would you find that useful?
Oh, I think that would be useful. In theory, it can be done already by some complex extrusions, I think.
Right, and rotations, probably true.
Yeah, I guess one of the things would be in all versions, future versions of FME, we're always looking at what people have done in terms of maybe these complex, more complex workspaces, and seeing if we can wrap that in a little shrink wrap, easy to use option for the next version to help things just smooth along the way.
That's right. I should also mention that Ulf was the original FME artist and created a number of different art pieces. We have an original Manson here at SAFE. We should get you to autograph it sometime, Ulf. But I can just imagine the 3D opens a whole new dimension to artwork, wouldn't it?
It certainly does.
Yes, yes. So in terms of wrapping up, if you are new to FME, there's a few things that you might want to try. I'll highlight to everyone that you may want to go and visit FMEpedia to see the 3D area in there. I just brought it up, and if you click on 3D, you can get to a bunch of interesting case studies that primarily Dimitri has done. So that's an interesting follow-up that some of you may want to do. And we've got other webinars coming up as well on June the 7th, interesting things about real-time data and FME. I would be remiss if I didn't mention the exciting World Tour stop that Ulf's group is organizing in Sweden. You can go to safe.com, WT 2012. Ulf, when is that going to be anyway?
September 5th and 6th. It's a 2-day event in Stockholm. And then we have a shorter one in Copenhagen too. But this one in Stockholm in Skansen is looking very, very good. We'll publish the agenda tomorrow, and we have already 35 presentations from several countries surrounding Sweden here. So.
And I'm very excited because I'm going to be there as well. And if you're an English speaker, you're very welcome at this event, aren't you?
Yeah, certainly.
And there's, of course, I think the Danes and the Norwegians and the Swedes can kind of understand each other in their native tongue, but they don't mind going to English to help out unilingual folks like myself. So I'm looking forward to that. And I'm bringing my whole family along, actually, Ulf. And so is there any chance of sneaking my kids into the nuclear power plant?
Oh, that probably won't happen.
Yeah, that's okay. That's okay. But they can at least drive by. Should be fun. Okay, I think for our last thing we're going to do here today, if you've stuck it out to the end, you should be rewarded. And we'll actually have a little contest here to see if anybody wants a free seat to a future FME training class. And we always play music. And today we got a tune from ABBA while you're doing your voting. And I think this was a Eurovision winning tune, wasn't it, Ulf?
Yeah, I think it was in '74.
And we should mention for all of the Swedish nationalists there, we'll probably shut off ABBA now. Okay, that's probably good.
At least
anyway,
you didn't start singing.
Yeah, that's true. Look at that. A lot of folks are interested that are very polite and some that aren't as polite, so thank you so much. But I wanted to mention that I think Swedish group won the Eurovision thing, or Swedish singer this year. Isn't that right, Ulf?
Yeah, it was a singer called Loreen.
Loreen, that's sort of like the Swedish version of Adele. Okay, so I think that's it. We'll be following up and sending you all some follow-up things, these slides, as well as a recording of this exciting event, and in addition, the workspaces we had. And our friend Mark Stokes has joined us in the room. Mark, is there any other questions that you think we should share with the group before the SpaceX capsule splashes down?
I think you answered them. There was questions about reading Revit, so that you answered that already. Formats for and tools for modeling underground pipes and tunnels.
Tunnels.
So we haven't looked at that yet, but
yes.
I'm sure we can. And then one of the questions was, what is BIM? Several people asked, what is BIM? So
yes.
throw that out. And
That stands for Building Information Modeling, and that's about techniques or technologies that can be used often during the early design and the building portions of a project to model in the computer completely everything that's in the building, down to the HVAC and everything else, very, very detailed things. Tools like Revit are, and Bentley Architecture are commonly used for that. And the big mystery or the holy grail in the GIS world is extracting the value that's in those things for ongoing future usage, often inside of a GIS. So anyway, great question. Thanks very much for that. So I think we'll wrap it up there. We're going to get and watch that SpaceX capsule land here, so we'll sign off. So thank you all so much. I really want to thank all the panelists and experts. Kevin, always a pleasure working with you. And thank you for your hard work for the last 15 years in the last, what is it, 7 or so on the 3D that made all this stuff possible. Really appreciate that.
No, it's been a pleasure. Thanks for letting me join you today.
And Dave, you've done lots of pioneering work with the 3D. Thanks so much for that. Dimitri, thanks for all your work making this more accessible to everybody. Mark, for all your tireless work answering all these questions. And Ulf, especially thank you for missing supper there tonight in Sweden and showing us the fantastic, really amazing work that you've done there. And I know it warms the heart of the team at SAFE when our products are used to help make the world a better place, to assist in otherwise difficult jobs and make things more efficient. So thanks so much, Ulf.
Yeah, thank you. It was a pleasure. So.
All right, so from all of us at SAFE and from Sweco, we're wishing you a very happy SpaceX landing day. Goodbye for now.